Alright, welcome. This lesson is just meant to refresh your minds. I will take the topic electrostatics in as far back as grade 7, grade 8, grade 9, grade 10, up until grade 11. Because remember, the topic is not taught in grade 12, but taught in grade 11, only assessed in grade 12. So we have learned the topic in the previous grades where you were introduced that you'd have like charges such as positive and positive. You know that these ones here, they will be repulsion, they repel, and you know that if you have positive and negative, definitely they will be attracting each other. So basically you were introduced on these concepts in those early grades. But then if we can just take to grade 10 and look at what is a charge. A charge is simple, it's just a positive and negative. But how does it arise? That would be the question maybe would need to answer to understand what is this charge exactly. Now, you would remember the experiment you do when you're in those early grades. Take a ruler, you rub it against your hair. Remember, you take your ruler, plastic, it will be neutral. Then you rub it against your hair. Then you put a piece of paper here. If you put a piece of paper, then the piece of paper would also be neutral, but the piece of paper would be attracted to the ruler. So once it is attracted, that would tell you already for sure there's something there. Something is happening. It cannot just be attracted. It means there must be positive and negative somewhere, somehow. Excuse me. So let's think about it. You rub your ruler against your hair. Remember, your hair is made of matter, and also your ruler there is made of matter. When I say matter, I'm simply referring to the fact that it has atoms. So let's assume that maybe your hair, I'll just make an example. Say maybe this is a plastic and a hair. Let's say a plastic is having atoms, your polymers, you know, your plastics. It is having so many atoms, but if you can just maybe take, let's say this ruler, even here with your hair, you still have carbon. Let's say you have carbon atom. I'll just make an atom. You have the nucleus with protons and neutrons. Then around the nucleus, you have your energy levels. The first energy level taking 2 electrons, and the second energy level they're taking 4 if it is carbon. So you have 4 electrons. Then if now again you think of your hair, depending on the atoms which are there, the electrons here will be transferred. The ruler steals, it takes away electrons from the atoms of your hair. The atoms in the ruler take away electrons from the atoms of your hair. Remember, if you think of your hair, you have so many strands of hair with millions of atoms. Now, within these millions, maybe each atom or maybe hundreds loses electrons, and we'll get to where we would calculate these electrons which are lost, lose. The electrons which are transferred in between will be so many, millions and millions. I'm not saying 1 million, 2 million. I'm saying millions, maybe in trillions, which are millions, millions, millions. So there will be so many electrons which are transferred between or in between the objects which are interacting. Now, once these electrons are transferred, not electrons, you would group them. Okay, let's look at this now. Your ruler there, once it gains electrons from, now it becomes, I'll just draw 3 minus signs there. Remember, these are not electrons. This is just to show the nature now of the charge, because we're going to say now the ruler will be negatively charged. Negatively charged. Okay, the charge is coming now. So the charge, in other words, it simply tells you whether a particle is having positive or negative. Now remember, when the ruler was still neutral, you had even number, the number of protons and electrons was even. Even meaning if there is one electron, there is one proton. So it means the number is equal. They are even. So now, once there are more electrons than proton, it becomes negatively charged. Now you bring this close to a neutral piece of paper. Now electrons, if it is neutral, if the piece of paper is neutral, it means each positive is accompanied by a negative. Then you bring it close, you bring this ruler close to this piece of paper. Then the electrons there will just run. The electrons will run or will be repelled. When I'm saying run, they will be repelled. These electrons will be repelled. Remember, okay, if you think back in grade 10, protons are found in the nucleus. They do not move. What moves in the atom will be electrons. So protons will not move. It's electron that must be repelled to the other side so that this side remains positively charged. So the electrons will move to the opposite end. Now, remember, this is just a line, but if you think of it, you would have atoms with so many atoms. So the electrons will be pushed to the other end in these atoms so that now the electron clouds moves. In fact, that's how we put it, so that this region here remains positively charged. So the other side becomes negatively charged. So the ruler can be attracted. I mean, the paper can be attracted to the ruler. All right. So I was trying to explain what is this charge. I think now you have an idea that, okay, if it is having more positive than, if it is having more negative than positive, it is negatively charged. Okay. Let me just maybe elaborate a little bit. Now, if now we're saying you have a sphere here, let's say this sphere is having, okay, the sphere there, two spheres. This one is having maybe 2 nanocoulombs. This one is having minus 5 nanocoulombs. Let's say this one is plus. That's how we always write. You have to indicate the nature of the charge. Now, what does this tell you? Negative here. Remember, these are just charges. They are not vectors. So the negative does not show direction here. it tells you the nature of charge here. So it means this one is negatively charged. Negative, it means there are more electrons than protons. Please understand that once there is minus, the charge, the sphere here is negatively charged. So meaning there are more electrons than protons. Alright? Then if it is positively charged, it means here there are more protons than electrons. So in other words, okay, let me bring this one. I think it's important that I also bring in this one. So this one, let's say it has 0 nanocoulomb charge. Hey, 0. Yes, it can be 0. Why? Because the sphere here is neutral. So it means there is even number of, or let me just say there is equal number of protons and electrons. So it is 0. Then once it is positively charged now, it means it has lost, electrons were transferred. It has lost electrons. Once it becomes positively charged, think of it as it was having a charge of 0. So now it is positive. So it means it has lost electrons and therefore yanjani, positive. So it means in its atom, or in the atoms of this whatever material is there, there are more protons than electrons now. Remember, when an atom loses electrons, it becomes positively charged. So this one, which is negatively charged, it means it has gained electrons. It is having more electrons than protons. So you would sometimes hear a language saying this one is electron deficient. Okay, or it has electron deficiency. It is in short of electron. This one is having an excess of electrons. It is having more electrons. They are in excess. All right, now I will proceed in the next video. I don't want to make them too long.